All right, today's topic, we are going to look at spheres and we are going to understand some of the properties and their surface area and volume. We will then solve a few problems with algebra. All right, so first off, a sphere is the locus, that means the location of all the points in space that are a fixed distance from the center of the sphere. So the sphere is all the points that are exactly the radius length away from the center. And then we have a hemisphere, which is just half of a sphere. So the radius goes from any point on the outside of the sphere into the exact center. Our equations are pretty straightforward. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. So we only need to know one piece of information for a sphere, and that is the radius. Okay, example 1, we are going to calculate the surface area and volume of this sphere. The diameter all the way across is 8, so the radius equals 4. Plug it into equations. This should be super simple by now. So the surface area is 4 pi r squared. So 4 pi times 4 squared. Four squared is 16 times 4 is 64. So we have 64 pi, and units are centimeters squared. That is the surface area. For volume, 4/3 pi r cubed. So plug in what we know, 4/3 pi, and then 4 cubed. 4 cubed is 64, and then 64 times 4 divided by 3 gives us 85.33 pi, and now our units are centimeters cubed. We can leave things in terms of pi, so you don't have to multiply by 3.14. Makes it a little bit cleaner. Okay, example 2, calculate the volume of a hemisphere. Our radius is 15, so let's plug that into our formula. The volume is 4/3 pi r cubed for a sphere, and plug in what we know, 4/3 pi times 15 cubed. 15 cubed is 3,375. So multiply that by 4 and divide by 3. We end up with 4,500 pi millimeters cubed. All right, that's the volume for a whole sphere. A hemisphere is half of it, so 4,500 pi millimeters cubed divided by 2. So that's 2250 pi millimeters cubed. All right, we can also work backwards. If we have a surface area, we can then find the radius and use that to find volume. So in this example, the surface area is 1156 pi centimeters squared. And since our formula for that is 4 pi r squared, divide both sides by 4 pi. Pi's cancel. 1156 divided by 4 gives me 289. Take the square root of both sides because that equals r squared. So I end up with r is 17 centimeters. plug that into my equation for volume. 4/3 pi times 17 cubed. 17 cubed is, a big number. Then multiply by 4 and divide by 3, and we end up getting 6,550.7 pi, and that's centimeters cubed. All right, our last example. We are going to triple this radius and see the effect on the volume. So let's first start off with our volume of the original. 4/3 pi times 3 cubed. 3 cubed is 27, and divided by 3 is 9. 9 times 4 gives me 36. So 36 pi centimeters cubed. My new one, when I triple it, I'm going to have a much bigger one that has my radius now is going to be 9 centimeters. So a much larger sphere. 9 centimeters is my new radius. Find the new volume. 4/3 pi times 9 cubed. 9 cubed is 729 times 4 divided by 3 gives me 972 pi centimeters cubed. All right, now if we compare them the way we did with cones, 972 pi divided by 36 pi, pi's cancel, and I end up getting 27 times bigger. So when we have a tripling of our radius, our volume becomes 27 times as big. It just so happens that 3, how much we increased our radius by, cubed is also 27. So the impact on that would be its cubed amount times bigger. So if it's twice as big, it would be 2 cubed times as big with volume, which would be 8 times bigger. All right, you do have an assignment that goes with this, so finish that up. This is probably going to be our last video for this semester. So enjoy, and we'll see you on the next